and your friends gather by a riverside in the summer, the sun dipping below the horizon, and someone hands you your very first beer, that first cold sip, slightly bitter, maybe floral or fruity, with a tickle of fizz, tastes like more than just a drink. What you're tasting is a result of hundreds of years of brewing knowledge, an orchestra of ingredients, and the quiet labor of microscopic organisms. Yet every beer, no matter how exotic, starts from the same four essential ingredients: water, malt, hops, and yeast. Water, which makes up more than 90% of beer, the minerals it contains, like calcium, magnesium, and sulfate, can alter pH, enhance hop bitterness, or round out malt sweetness. Malt, typically made from sprouted and roasted barley, is the beer's soul food. It supplies sugars for fermentation and layers of flavor. When malt is kilned, sugars and amino acids undergo the Maillard reaction. Depending on how it's roasted, malt can bring notes of caramel, biscuit, coffee, or dark chocolate, setting the beer's color and body. Hops are the spice rack of beer. They add bitterness that balances malt sweetness and contribute essential oils that create aromas ranging from citrus and pine to herbal and earthy. Lastly, the transformation from sweet grain soup into beer is powered by yeast. Yeast is a single-celled fungus, often overlooked, yet it's the microscopic brewmaster. During alcoholic fermentation, yeast consumes simple sugars like glucose in the absence of oxygen and converts them into ethanol and carbon dioxide. This is what gives beer its alcohol content and bubbles. But that's only the beginning. Depending on the conditions, yeast also produces hundreds of flavor-active compounds that shape each beer's unique aroma and mouthfeel. And here's where things really diverge through two main fermentation styles, top and bottom. Top fermentation, used in ales, employs Saccharomyces cerevisiae. The yeast thrives at warmer temperatures and rises to the surface during fermentation. This process is fast and expressive, producing fruity and spicy byproducts like isomal acetate, which smells like ripe bananas. By contrast, bottom fermentation, used in lagers, involves Saccharomyces pastorianus, which works slowly at cooler temperatures, settling at the bottom of the vessel. The result, a cleaner, crisper beer with fewer flavor byproducts that's perfect for showcasing malt subtlety and hop precision. Fermentation doesn't just make alcohol, it's a universal survival strategy. In the absence of oxygen, microbes adapt. Bacteria like lactobacillus create lactic acid, giving us sour beers, yogurt, and kimchi. Fungi break down proteins in soybeans and grains to make miso, tempeh, or soy sauce. Whether baking bread, aging cheese, or brewing kombucha, fermentation is one of the oldest biotechnologies in human history. But you might wonder, why do we wait until adulthood to enjoy beer? Well, the enzyme alcohol dehydrogenase converts ethanol into acetaldehyde, a toxic hangover causing intermediate. Then aldehyde dehydrogenase converts it into acetic acid, which eventually broken down into carbon dioxide and water. In adolescence, this enzyme system is often underdeveloped or less active, causing acetaldehyde to linger longer. That's why young people often experience more intense reactions to alcohol, even in small doses.